Condensation polymers. Definition of condensation polymerization involves two different types of monomers, each with at least two functional groups. Each functional group reacts with a group on another monomer, forming a link, therefore causing the polymer chains, right? So 3 examples of condensation polymers: polyamides, polyesters, polypeptides. State what is called condensation polymerization. Each time a link is formed, the water is lost, or a small molecule is lost. State what reaction produces polyamides. The reaction between the carboxyl groups of the dicarboxylic acids reacting with the amino groups of the diamines produces the polyamide, forming the amide links. Carboxyl groups of the dicarboxylic acids reacting with the diamines, the amino groups of the diamines forming amide links. So you can see here the dicarboxylic acid, the diamine, the carboxyl group of dicarboxylic acid react with the amino group of the diamines, OH and the H here, you form a H2O, and then that's your amide link joins together. Nylon 6,6 is polyamide made from 1,6-diaminohexane and hexane dioic acid and is used to make clothing, carpet, and rope. Kevlar, a polyamide made from 1,4-diaminobenzene and benzene-1,4-dicarboxylic acid, used in bulletproof vests, boat construction, and car tires. Say what reaction produces polyesters. The carboxyl groups of dicarboxylic acids reacting with the hydroxyl groups of the diols, forming your ester links. Carboxyl groups of dicarboxylic acid react with hydroxyl groups of diols. So the previous one that we just went through, carboxyl groups of dicarboxylic acid reacting with amino groups of diamines. In this case, carboxyl groups of dicarboxylic acid reacting with hydroxyl groups and diols from the ester links. Polyesters polymer is joined by ester links. So you got your dicarboxylic acid, your diamine. I should say actually no. It should say diol. Your diol, OH and H. You form your H2O, and then that's your ester link, C-O and your O. Terylene and PET formed from benzene-1,4-dicarboxylic acid and ethane-1,2-diol, used in plastic bottles, clothing, sheets, and sails. State how condensation polymerization is reversed by hydrolysis. What happens is water molecules are added and the links are broken. So in this case, your amide link plus 2 and H2O, you form your dicarboxylic acid and your diamine. So what you have to look at is which one is it first. Well, I can see here, this is a polyamide because it's the amide link. And what is polyamide? What the reaction produce polyamides are carboxyl groups of dicarboxylic acids reacting with the amino groups of diamine. So I'm going to form a dicarboxylic acid and the diamine. That's what I'm going to form. There's your dicarboxylic acid, there's your diamine. If it was an ester link, C double bond O and an O there, and an R there, then because I'm reversing it by hydrolysis, well then it's carboxyl groups of dicarboxylic acids and the hydroxyl groups of the diols. So I'm going to form a diol and a dicarboxylic acid. Why are condensation polymers stronger and more rigid than addition polymers? They're made up of chains containing polar bonds and van der Waals forces, permanent dipole-dipole forces, and hydrogen bonds between the polymer chains. Polyalkenes, well, they're addition polymers and they're made of non-polar carbon chains, therefore they're unreactive and inert, therefore non-biodegradable. Polyesters and polyamides are condensation polymers. They have polar bonds and chains and are open to attack by nucleophiles. They're biodegradable and broken down by hydrolysis. Burying waste plastics. Now that's all the key information. The rest of this information is just like, how do I say this? It's more like if you don't learn it, okay, it could still come up in the exam. It's probably not likely to because it is just a simple topic, just a bunch of information you have to just memorize about plastics and burning and that. But if it does come up in the exam and you haven't gone through it at all, you're going to struggle a lot. The reason I say that is because it is just about burying plastics, environmental how it affects the environment and all of that. But burying waste plastics, landfill, dealing with waste plastics used when plastic is difficult to separate from other waste, not in sufficient quantities to make separation worthwhile, too difficult to recycle technically. Landfill is a cheap and easy method of waste disposal but requires area of land. As waste decomposes, it releases methane. Leaks from the landfill sites contaminate water supplies. Waste plastics are burned heat to make electricity. Process carefully controlled to reduce the release of toxic gases. Waste gases formed from combustion pass through scrubbers, neutralizing the gases. And then the final part, to state the two ways of recycling plastics: plastics melted and remolded, or the plastics cracked into monomers used to make more plastics/chemicals. Recycling plastics reduces the amount of waste into the landfill, plus saves raw materials. Cost of recycling plastics is also lower than making plastic from scratch. However, plastics can be easily contaminated during the recycling process, and it's also technically difficult to recycle plastics. Plus, collecting, sorting, processing plastics is more expensive than burning.